Hello, everyone. I'm Stéphane Lafortune of the Electrical and Computer Engineering Division of the EECS department at the University of Michigan. So I am delighted to introduce Dr. Tanya, who is the Senior Associate Director of Energy Innovation at the Bipartisan Policy Center in Washington, D.C. Tanya is a Michigan native. She earned her Bachelor's of Science in Electrical Engineering from us in 2011. Then she went on to earn her master's and doctoral degrees in electrical and computer engineering from the University of California at Santa Barbara. After her PhD, Tanya worked on energy policy in the US Congress, and then President Biden appointed her Chief of Staff of the Office of Science at the US Department of Energy. She has also served as a professional staff member on the House Committee on Science, Space, and Technology. Here in ECE, we are very proud of Tanya's accomplishments, and she received the ECE Rising Star Alumni Award in October 2022. She delivered a lecture on that occasion that you can find on the ECE website. Tanya, thank you for joining us today. We're excited to hear your insights on energy policy. So I'm joined by Lydia Fraz here, who is an undergraduate student in the College of Engineering with an interest in sustainability, and she will be asking the questions along with me. So Lydia, would you please go ahead with the first question?
Yeah, so I was just wondering if you could kind of tell us about your journey from Ann Arbor, then to the highest levels of government, and then to where you are now in that national think tank.
Yeah, so I started out in the engineering space, as you heard, and took a path that I think was a little bit unconventional, where I didn't realize until midway through my PhD program that I wanted to try and go for a different type of career path. You know, for the longest time, I kind of had my head down just doing engineering and thought I would end up working, you know, at like Intel or something like that, or trying to have a career as a researcher. But really was realizing that that wasn't what got me excited every day. Like those just weren't the kinds of problems I wanted to solve. I didn't want to dedicate my time every day to solving basic science problems. I wanted to focus on something a bit bigger. And so I did a lot of work during my PhD to kind of figure out, well, okay, if I'm not going to follow this path that I thought I was going to follow, what will I do instead? And started exploring alternative career options, and learned during that time about this organization called the American Association for the Advancement of Science, called AAAS, and found out that they sponsor a fellowship program for people like me who either have a PhD in the STEM field or a master's degree with some work experience to make that transition into the policy space. And so I applied for that program, was lucky enough to get in, and that was really what launched my career in the policy world. And so through that fellowship, I did a one-year fellowship in the Senate. So I worked for a year for Senator Chris Coons, who is one of the senators from Delaware, and got to dip my toe in on what it's like to work in Congress on Capitol Hill, and just really loved it. And as you heard from my introduction, was lucky enough to find a job afterwards, which kind of helped me build my experience in this space.
Thank you so much. That was super informative and really helpful and very good to know. So the next question that I have was, could you describe the key technological challenges in reducing greenhouse gas emissions in the US, and then like your perspective on that and how you feel personally?
Yeah, so my work now at the think tank is focused on innovation. And when we say innovation in this space, what we mean is what it takes to go from that initial idea or concept all the way to a product in the marketplace. There's a bunch of different steps in that process in order to make that happen. And there are many opportunities to fail because of all the various steps that it takes in the process. And so first, we need to think about if you're able to prove something, through theoretical models on a computer. And then if you're able to prove something for the first time in a lab, let's say like in a test tube, and then scaling that up, what we call the pilot stage. So proving that a concept works under real world conditions, and then thinking more about engineering issues rather than just scientific issues, and then proving that an idea works at scale. So let's say we're talking about wanting to, let's say, clean up natural gas power plants with carbon capture. So demonstrating that your concept works at a natural gas power plant, let's say, retrofitting your technology onto that. And then scaling up past that is what we call the deployment stage. So actually getting to the stage of having a functional company where you're building many of these and selling them to others and being able to be a profitable company. So that's a lot of various steps in the process. And the federal government has various policies and programs to assist with each of those stages, to help scientists, engineers, and entrepreneurs navigate each of those various stages. And one thing that's super exciting at this moment in time is that the federal government passed some really important pieces of legislation last year. Two foundational bills. One is called the Bipartisan Infrastructure Law. The other is called the Inflation Reduction Act, that dumped a lot of money into those stages of innovation, which is huge. Like, we're talking billions and billions of dollars. This is like, I think, the most money our federal government in the US has ever spent on innovation, to the point where other countries around the world are now like kind of freaked out and playing catch up, because they're like, oh no, the US is doing so much, we need to do more, which is amazing, and which is exactly where we want to be. And so in terms of the technological challenges that we're facing in this moment when it comes to clean energy technologies, I think that's really the key, is that we need to be looking at how to scale up these technologies. Because in the US, historically, we've done a really great job on the basic science side. We've done a really great job like coming up with interesting ideas. We also have a great ecosystem for entrepreneurs where people are able to create startup companies. But then when you go beyond that, to going from startup to functional company at scale, that's where we've actually really struggled. And we've seen a lot of startups go to other countries to take their ideas and try to, become fully functional companies there. And we want to keep a lot of that economic development here in the US. And there's a lot of bipartisan interest in doing so. And so those investments that Congress made last year, I think, are going to be very, very helpful in making sure that we can actually achieve those goals of economic growth, while also making sure we're making advancements on the clean energy technologies that we'll need to address climate change.
Thank you so much. And then the next question I was wondering about is, with all those technologies that you've mentioned and other technologies that you know of, which ones do you find to be the most promising right now?
Yeah, I think the exciting thing about this moment is that our government is really investing in all of it. I think it's really important that we not try to decide too early on what ideas should win, and try to give all ideas a fair chance so that we can make the quickest progress on addressing climate change and invest in the technologies that prove to work at the fastest scale. I will just highlight a few really cool emerging areas that I think you all who are undergrads can show some real leadership in if you're interested in going in that direction and working at one of these companies. So there is a whole field called carbon dioxide removal, which is exactly what it sounds like, that is focused on removing carbon from the atmosphere. And there's a lot of different ways to do it. One technology that's become very popular is called direct air capture, which literally it sounds kind of crazy when you describe it, but it's like a big bunch of fans that are sucking in air and then absorbing carbon out of the air, and then, storing that underground or some other way, putting that carbon away so that it's been removed from the atmosphere. And there's other approaches too. There are concepts like being able to absorb carbon in trees and then store it in soil, soil sequestration. There are agricultural, there are intersections with the agricultural sector as well. So really, really interesting field that we've only just barely scratched the surface of at the federal level that I think is going to become a much bigger conversation in the coming years. I'll also highlight fusion energy, which for the longest time was something that honestly, I think folks kind of like laughed at when we thought about that being a commercial technology. A lot of folks would say like, oh, for the last 50 years, fusion has just been 10 years away from becoming commercial. And it was just kind of this running joke in the energy space. But I will say some really important scientific breakthroughs have happened in the past year that I think is making this more and more reality. We are seeing fusion startups in the US, and I think there's actually like a fusion private sector that's really growing and starting to emerge, which I think is super exciting and I think is going to be really, really important. And then the last thing I'll mention is that when we're thinking about these technologies, we, at the end of the day, we really need to have what we call baseload power. And what that means is basically power that isn't dependent on whether the sun is shining or whether the wind is blowing, that we can have electricity available 24/7 whenever we want. We're the US, we're America. That's how we're used to living our lives, right? We also want to make sure that, you know, when the weather gets really, really cold in the Midwest or when it gets really, really hot in California, that folks have access to air conditioning and folks have access to heating to make sure they can make it through these extreme weather events that are becoming more and more common. And because of that, we are going to need steady sources of power that are available at all times that we know that we can rely on. Historically, that has been coal. We're definitely trying to move away from that. The economics of coal are very unfriendly now. So for that reason as well, our country is moving away from that. It's starting to be replaced by natural gas. But again, that is a source of a technology that does have emissions associated with it, and we don't want to see that. And so there are a few options available that can help provide that kind of baseload power to make sure that we have 24/7 electricity. And I think that's the other piece of this puzzle. And I'll just highlight a few options that we have. So there is a technology called energy storage, which can be paired with renewable energy to allow for us to draw on those sources when the sun isn't shining, when the wind isn't blowing, to make up for the fact that, you know, maybe we can't have resources available from solar or wind. And energy storage takes a variety of forms. Sometimes it's batteries. Sometimes it is, for example, like storing hydrogen or some other type of clean fuel and using that when you need it. So that takes a variety of forms. And there's also nuclear energy, which I think historically has had a bit of a fraught conversation just in terms of the waste issues, the safety issues. But I will say that there are new, what we call advanced nuclear technologies that are very, very different from the nuclear power sources that we have seen like negative headlines about, you know, in the past, that have really corrected for those issues. And I think are really, really promising moving forward in terms of a secure, reliable, and very, very clean electricity source that I think you all as young engineers would be really well poised to contribute to.
Thank you so much. That's really interesting to know about kind of all those like interconnections and then how all of that kind of goes back to our daily lives and what we're learning every day. So thank you.
Thanks. Felix Son has just joined us and we'll ask the 3 remaining questions to you, Tanya. Felix, please.
So the first question that I have for you is, how can we achieve the goals that we've asked about?
I think the most important thing is to get aligned, to be on the same page to make this happen. So I've been working in this space since 2017, and in that time, which honestly feels like a bit of a short time, I have seen so much growth in how much this is a bipartisan conversation and not just a conversation of a single political party, which is really, really important. I think, America is a country that is vast and very diverse, and people have a lot of different opinions. And having grown up in Michigan, I saw that as well, just in my personal life. Folks have all sorts of political views on how our country should be running and operating. And so we need to be on the same page, and we need to be aligned that this is a goal at all for our nation. And I think we are absolutely there. And that is huge, because when I first entered this space in 2017, it didn't really feel like we were all on the same page. But now we are, because people from all over the country in all different pockets are experiencing the effects of climate change in different ways on a very personal level. And so I think everyone's kind of had, it feels that call to action. So where do we go from there now that we, have established the need? Well, next comes aligning our interests around the solutions. And so just before this, I was talking about the different technologies that are available to us in order to make progress on addressing climate change. And I think it's very important to not discount certain technologies. When we were talking, for example, about baseload power and the need for reliable power generation sources so we can have 24/7 electricity, I think there are some folks who hear about a technology, for example, like carbon capture, which is focused on capturing carbon from an emitting power source like natural gas or coal-fired power plant. And some folks are concerned that if we're investing in that technology, it means that we are trying to perpetuate the life of oil and gas companies, for example, and ensure that those technologies stick around longer. With my experience, both as an engineer and in the policy space, I don't think that's the case, because we know that, for example, first of all, we're going to need reliable electricity sources, but also that this is a global problem. And that while in the US, we've been dependent on coal for a long time and are now transitioning away from that, other developing economies, there might be a future for coal, and there might be a future for coal for several decades to come. And I think it is a huge missed opportunity if we do not help those developing countries become clean as well by developing the technologies here and bringing down their costs and bringing them to commercialization so they're cheap enough for those countries to be able to install and implement. This is really a global problem. Like, the sky is one sky, the atmosphere is one atmosphere, it's all interconnected. And so, emissions that we produce here affect other countries, and the same for us. Emissions produced in other countries affect us as well. And so that's something I would really emphasize, is like, we shouldn't be discounting any technologies at this stage, and really need to remember that we all have to work together to advance these common goals.
So my next question for you is, how can undergraduate students become involved in addressing these challenges?
Yeah, so there are a couple ways. So for engineering students in particular, I would say that the opportunities available to be an engineer at a climate tech startup at this moment are so many. It's amazing. Climate tech startups, there's been more venture funding available for them this year than any other year in the past. Actually, in 2022, it was up to $80 billion, which is huge. That is a huge amount of money. The investment in climate tech startups has just been rapidly increasing the last few years. And so there's a ton of jobs out there. And I think it's a really cool space for you all as engineers, because you are able to apply your technical talents to something that also is very mission driven. And you know that you're developing a technology that's going to help save the world, in a sense. And I think that's really, really cool. So if you are excited about the technical aspects of climate change, you can definitely go work at one of those startups. And then the other opportunities, I'd say, are really in the policy space, where I work. Tons of opportunities there. I am now at a think tank, and we have internships every year So if anyone's interested, please reach out. But yeah, we have internships for undergraduates who are interested in just dipping their toes in the water, trying to understand what the policy space looks like. And you can grow and develop into a policy expert through your expertise there. You can also try to work at one of the federal agencies, the Department of Energy. Like I said earlier in this conversation, is spending billions and billions of dollars that Congress gave them in various technology and innovation projects. And they need a lot of help to do that. And they're also hiring a lot and need help. And so even within the policy space, there's a whole bunch of different career opportunities, some that range from more technical to some that range more where I sit on really the idea generation and advocacy. So lots of opportunities available to folks in the engineering space for careers in this field.
So last question. So more generally, how has science policy kind of arrived in Washington?
Yeah, so I wanted to share a slide here that I think really encapsulates this process and how it can be a little bit of a wild process. So I wanted to take the case study of a question that I had investigated, a topic that I investigated when I was working in the U.S. House of Representatives, which was the question of how we could reduce emissions in the manufacturing sector. So the manufacturing sector is responsible for about a third of emissions in our nation, which is pretty significant. We have historically focused a lot on reducing emissions from power sector as well as transportation, because transportation also has a lot of emissions associated with it. But the manufacturing sector is also, like I said, a huge source of emissions, but a very difficult sector to tackle because it's so many different things, right? When you think about manufacturing, like the way that you make cement and steel is so different from the way that you make cars, is so different from the way that you make like glass and plastics. Like there's so many different processes there. And so it's a very complicated problem, but it was also one that our nation hadn't really thought a lot about how to address. And so I wanted to just pull back the veil a little bit and explain the process that I followed working in Congress to develop a bill to address this. And so the first step, as you might see, is researching the problem. So understanding the lay of the land, but also understanding what is the issue here, and identifying what are the relevant policy solutions to address the issue. For example, it could be an issue of like there isn't enough research funding, so we need to actually invest more on the basic science side to understand what the issues are. Or it could be an issue of the technologies are out there, but industry isn't adopting them because the technologies maybe aren't cheap enough. So maybe there are some sort of government incentives that need to be provided, or there needs to be more investment to make the technologies cheaper so that industry will actually want to adopt them. So sort of researching the problem and understanding the landscape. And then understanding like I said, the policy solutions. So is it research funding? Is it tax credits? Is it something else? Like there are these policy tools that are commonly available at your disposal, and sort of matching those up with what the problem to figure out what you actually want to propose. But importantly, as you can tell, I'm very bipartisan. You want to identify the policy solutions that are politically viable. It's very rare that you can achieve policy goals with the support of a single political party in the US. And so you really need to make sure that whatever policy solutions you're proposing are solutions that would be able to have the support of both Democrats and Republicans. And so with that in mind, once you've done that work, you develop a framework for a legislative proposal. And this is when things really get interesting. So you develop, a draft bill, and then you work to refine that bill with feedback from key stakeholders. With a project like this that was talking about emissions in the manufacturing sector, that involved a lot of different folks. It involved some of the major manufacturers in our country. It also involved folks who are involved with, for example, like, how do you quantify whether a product is clean and what does that look like? And sort of like standard setting in that sense. It also involved entrepreneurs and startups who are developing some of these early technologies and solutions in this space. And so you want to make sure, the reason you do this is that you want to make sure that whatever policy proposal you are proposing will actually address the issues that you've identified and will actually be useful in making progress on the issue. You don't want to do something that like sounds good, to Congress and sounds good to the government, but isn't actually going to have the impacts that you want. And so that's why we have this really important step. So you refine the bill, come up with a policy proposal that's more reflective of what's needed. And then you work to build bipartisan support. And so that's why it's important to just keep in mind that political viability from the very beginning. You introduce the bill, and then there's several steps to actually get the bill into law. So you have to work the bill through the committee process, which includes holding a hearing on the bill in which you invite experts to come testify in front of Congress on the issue and how the bill would or wouldn't solve the problems at hand. Eventually, you find a legislative vehicle to pass the bill into law. So one thing a lot of folks don't realize is that it's very rare that any one individual bill is passed into law on its own. Typically, what happens is that collections of bills that are a package of several ideas will pass into law every couple years together. And so part of what you want to do is keep an eye out for like, okay, what packages are seeming like they're gaining momentum within Congress that maybe I can attach this idea to. And then after you've passed the bill into law, more work still needs to be done. So there's a difference. There are these two terms that we use in the policy world all the time: authorization and appropriations. Authorization just means that Congress has told the government that you should do X, Y, and Z. So for example, it could be something as simple as you should create a new research program for finding technologies that can help reduce emissions in the manufacturing sector. That's a really simple one. Or it could be something more like something bigger, where Congress says, we are going to create a new tax credit that will actually reduce the amount of taxes that manufacturers have to pay if they are using clean manufacturing methods. So that first one, where you're just telling Congress, let's say, or telling the agency, let's say, to create a research program, that doesn't have any funding attached to it. It's just direction to the agency. And so in theory, the agency could devote very little money to that or could devote a lot of money to that, but Congress isn't actually sending them any resources to do so. Something like a tax credit is different. That's something that the agencies have to do. That's something that would be immediately implementable. But all that to say, that's why you also, in the first case, in those types of examples, need to pass funding for the bill. And that's what we call appropriations. And so that is a separate process. The government typically passes a funding bill called appropriations every single year. And so once you've passed the bill into law, you also need to make sure that there is funding for the program through that appropriations process. Sometimes a bill can pass into law and a program can be authorized, but it could be years before the program even receives funding. So sometimes there is a large gap. And so with this example, we passed a bill into law in 2020. And then we had, I was mentioning earlier, the bipartisan infrastructure law that passed in 2021, which actually did provide funding for this program. And after that, so after the funding has passed, then the agency has to implement the program. And that's also a very, very important step in the process. And that's the process that we are in currently in this example. And so the agency once it's received funding, then has to do a lot of work to actually get that money out the door and do it in a way that reflects the intent of what Congress wanted out of the program, as well as ensuring that it's being implemented in a way that actually makes progress on the issue at hand. And so in this case, the Department of Energy is trying to work to get a lot of insight from the private sector on what's actually needed, insights on how to spend this money most effectively to make progress on the issue. And ourselves in the think tank world are also helping to elevate some of those voices to make sure that these billions of dollars that DOE is spending right now actually makes progress on climate issues in the coming years. And so just to give you a sense of scale in terms of how long this takes. So from step one, when we first became aware of this problem and started researching it, that was in 2019. And so this takes a really long time. And typically, I actually would say this is kind of quick. It usually doesn't happen this quickly. We were just super lucky that we had, the bipartisan infrastructure law and a lot of action happening in the energy and climate space. But it can often take like up to a decade or more to go from that initial first step to all the way to the end.
Well, Tanya, can I follow up with a question here? And to paraphrase Bill Gates, I will ask, in this bill that you worked on and the most recent appropriation, what is the plan for cement, which is making cement generates a lot of greenhouse gases, right?
Yeah, cement is a really interesting one because the way that the chemistry involved in processes for making cement inherently emit a bunch of carbon dioxide emissions, which isn't the case for other industrial processes. Like, for example, sometimes during manufacturing, you just need to create really, really high temperatures in order to make something. And so then you need to burn a fuel in order to get to those high temperatures because that's the only way to get there. That's not true for cement, where, like I said, the actual chemical process involved in making cement releases a bunch of carbon dioxide. So right now they're looking at developing carbon capture technologies in order to be able to collect the carbon emissions from cement. So yes, an issue that is of great interest right now in our DC policy circles. They're also looking at seeing if there's a role for the federal government to be the purchaser of that cement. So you might imagine, if you are creating this sort of cleaner cement, it's probably more expensive because you've had to stick on, for example, a carbon capture facility in order to make it cleaner. But there is this thing called the green premium, which is the idea that cleaner products can be more expensive. And so there have been proposals to have the government be a first purchaser of those newer and more expensive cement products to help then bring down the cost, help with the commercialization of the technologies so that by the time the rest of folks are ready to purchase that, it'll hopefully be at a lower price and that the green premium will hopefully have disappeared and be on par or maybe even cheaper than the rest of commercially available cement.
Thank you. Lydia and Felix, do you have any further questions or?
Yeah, I do have one more question actually. When you mentioned that this bill that we're working on right now took a lot quicker than usual because of how much things were going on within the energy sector, do you think because of this we can expect more focus to be put towards bills and more bills to be passed into law at this rate because of this?
Yeah, we've had a lot of really great action in the climate and energy space. I'd say since 2020 to present day. And I do really want to emphasize that I work at a bipartisan organization and get the question all the time of really, can we even do anything bipartisan anymore, right? People just don't believe that that's happening. And I just really need folks to know, it's absolutely possible. We're doing it every day. There's a lot of places for bipartisan agreement. those just aren't the types of things that make headlines, because controversy makes headlines, not agreement. So yes. So in answer to your question, Felix, yes, I absolutely think we're going to see more bills passing to unlock some of the issues. Congress has done a lot already. So I think a lot of the work really is on the agencies and who are spending the money and the companies who are, receiving the money. But there are still some remaining issues that I do think are going to be worked out on a bipartisan basis in coming years.
Thank you.
Okay, I have one question that's kind of just related to like general public, not even engineering students. But when you're talking to people about ways that they can like reduce their own carbon footprint, what are the biggest things in your opinion? Because you see a lot like recycling or going vegetarian, but on the large scale, do you see those things really making an impact? Or is that more kind of like a commercialized view of reducing your carbon footprint?
Honestly, I really struggle with this question because I don't believe that individual action is the only thing that can fix the problem. I think we need both, like the large technology changes we're talking about and individual action. Going by the numbers, the transportation sector is the highest emitting sector in our nation currently. And so it sounds really silly, but like that's something I really try to focus on, is just like not driving my car, which I drive my Ford Focus that is from 2011. It's super old and like not super efficient. I don't drive an electric vehicle, but I do think, as much as possible, taking public transportation and doing ride shares and all that, I think is actually really important. Just like that's what the numbers show us in terms of where the emissions are coming from in our nation.
Thank you.
Well, thank you so much, Tanya, for participating in this interview. Really enjoyed listening to your insight. And so this will be shared with the students in the class that we will offer, called Challenges and Opportunities in Reducing Greenhouse Gas Emissions. So thank you again. Thanks, Felix. Thanks, Leah.
Thank you.
Thank you.
And we look forward to seeing you on campus again in the future.
Yeah, of course.